Hello there guys, this is Teacher Krishna and welcome to our next class for the third unit. This is a class that is part of the high school and of course it is intended for 7th high school and BYS. Just like you know, our subject is science and today's lesson is part of week number 23. Thank you a lot for coming and let's go over our presentation today. Remember to have your notebook with you in order to make today's summary. Just a little bit of information to refresh your mind about the parts that your summary must include. Make sure to write down your date, the ending mind, the title of course, the summary itself, and add some extra decoration to your summary today. Alright, and let's continue. Today we're going to be studying lesson number 2, Earthquakes and Seismic Waves, pages 110 to 117. And the ending mind for today is the following. Identifies the 3 types of seismic waves and how they are used to locate the epicenter of an earthquake. It's something very important to notice. Notice that today we are studying lesson number 2, but this will be like the part 2 of the lesson, right? Because last week we were studying the first section of lesson number 2. Today, we are only going to finish with pages 115 to 117, from what I remember, all right? So, let me give you a small summary of what we are going to do today. So, first of all, you need to watch this YouTube video and make a summary in your notebook. Number 2, you need to read pages 116 and 117 and complement your summary. Something very important, please, when you complete the exercises, because you need to complete the exercises as well from pages 116 and 117, use pencil. So during the mid-session, we're going to be double-checking the exercises and, of course, the answers, just to double-check that you have gotten them right. And lastly, you need to upload pictures of your summary and books exercises. So you are going to upload them to Google Drive, but I will give you more information about it during the meet session. All right, so make sure to have the pictures ready with you, and I will let you know how to upload them during the meet session. All right, first of all, we're going to start by talking about how is an epicenter located. And right over here, we have a diagram of some seismic waves. And of course, the epicenter will be right above the focus of the earthquake. But how do scientists are going to locate the epicenter? Let's go over the topic. So geologists use the seismic waves that an earthquake produces to pinpoint its epicenter. So the seismic waves that the earthquake produces are essential in order to find out about the epicenter. They use the data gathered from several seismograph stations. So it is not possible to locate the epicenter of an earthquake just by using one single seismograph. So in order to make it a little bit easier, what scientists do is that they compare the information they have from different seismograph stations. And remember that P waves arrive first. Then they are followed by S waves. Yeah, that is something very important to remember. Like the first waves that we are going to feel are going to be the P waves. And then we're going to feel the S waves after a little while. But you have to notice that they are very close from each other. All right? And S waves travel faster than P waves. That's something very important to notice as well. And even though S waves are produced after P waves, we feel them almost right after each other, because S waves are going to travel way faster than P waves. And geologists compare both to determine how far away the earthquake was produced. So, of course, since you are measuring both types of waves, you are measuring the P waves as well as the S waves. And of course, as geologists already know the velocity of each one of these waves, they can use it to actually pinpoint the epicenter and of course the distance from where it was produced. All right. Let's continue. Here we have a diagram that represents the speed of P waves and S waves. Just like you can notice, right over here, we have the arrival time in minutes. So here we have 0 minutes, 2 minutes, 4, 6, 8, 10 minutes, and so on and so forth. And right at the bottom, we have the distance from the epicenter, which will be 0 kilometers, 2,000 kilometers, 4,000 kilometers, and 6,000 kilometers. So, and remember that the ones that arrive first are the P waves because they are the first ones that are produced. Later on, the S waves are the ones that are produced. So, let's analyze a little bit about the graphic. So, let's analyze what happens 2 minutes after they are produced. Or let's go with 4 minutes. I think it'll be better, 4 minutes. So, just like you can see right over here, after 4 minutes, the P waves, which is the blue line that we have right here, traveled up to 2,000 kilometers, right? But let's analyze the S waves. So what happens with the S waves? In this case, after 4 minutes, they has traveled 1,000 kilometers. All right. And of course, we can continue a little bit more. Like what happens at the 8 minutes? So at 8 minutes, how much have the S waves traveled? Well, you can notice that after a little while, after 8 minutes, it probably has traveled already around 2,500 kilometers. But if we analyze the P waves that we have right here, you can notice that it had traveled probably 4,500 kilometers already. All right, so let's continue. I'm sorry about it. There you go. Let's continue. So how to locate it? How do scientists actually locate the epicenter of the earthquake, of course? So just like it says here, if you know the data from 3 seismograph stations at different locations, you can draw 3 circles and find an intersecting point. This is where the epicenter is located. All right. So here you go. Notice that we have 3 different seismograph stations. We have one in Chicago, one in Savannah, and one in Houston. So after they have failed and analyzed the data that is coming from the earthquake, they are going to draw a circle around them, which is of course going to signalize a possible point from the earthquake, of course. So if the 3 seismograph stations do exactly the same, they represent the information that they got from the earthquake waves, and they draw a circle with the possible location where it could be. At the end, you are going to find what we know as the intersecting point. So, of course, you can notice that right here, it will be where the earthquake happened. But what is going to happen if we only have 1 seismograph? For example, just in Chicago, well, we are not going to be pretty sure about where it actually was originated. Because, just like right over here, it could be here, it can be here, it can be at the top, it can be at the bottom, and so on and so forth. The same if we just have 1 seismograph in Houston. Like from here to here, it's possible that we have all of the earthquake being produced. But, of course, once you use the information from different seismographs, you are going to find out that the intersecting point will be right over here. All right, and that's pretty much our presentation for today, guys. Thank you a lot for coming. And I will be meeting you in the mid session just in a couple of minutes. All right. So take care of yourselves and goodbye.